Alright, we're going to create a guide using the Blue Sky Bio software. First, you will load the raw dicom files, locating them onto your computer and selecting them. The software will then import all the files and reconstruct it in this viewer format. Then we will load an STL file, which we will find that file within our system and load it directly into the software. It'll bring us to this screen, and we will orient that 3D model to where we can select teeth on the model and on the scan. You'll notice the scan was taken with the teeth apart. To make this a little bit easier, you'll hold down select and start clicking on points on the model and also on the CT scan panoramic shaped image. Once you have selected enough points, you will then click align, and the computer will think through the process of aligning it. And in this particular case, the alignment goes very well with minimal adjustments needed. But the next step is usually the hardest part, is making sure that your model is aligned appropriately. So once it is aligned, there you go, click align, and you can see this one aligned very, very well. You can scroll through every image to make sure it's okay. This is one of our favorite views. You scroll superior and inferiorly to make sure that it actually outlines the teeth very well. If not, you would go in and manually move it until it is ideal. We like to change the color to red, change the surface color, and again scroll through and just identify that it is aligned very, very well. If it is, then you can go on and design where your teeth would go. In this case, first we go in and select and modify our focal trough, and we drew our own panoramic curve, and now we adjust it until you're happy with how it appears on in your other fields of view. In this case, we're pretty happy with it. We like how it looks, and we're going to align where those teeth are, or the teeth are missing, to virtually wax up the teeth that are missing. I like to do this by changing the model color, because the teeth usually come in red. So we change the model color to green, and now we're going to add teeth in that position. There you go. We add a tooth. You'll just modify it. I like this 3D view. It's so much easier to look at the size and shape of the teeth and make sure they're aligned properly. You can lengthen them. If you click on those little balls, those will enlarge it. If you click on the pink one, it'll enlarge it in 3 dimensions, in all dimensions. If you click on the blue one, it'll lengthen it or shorten it. The arrows will allow you to position it right and left, forward and back, or mesial and distally, and superior and inferiorly. The circles will allow you to rotate them in any direction, and again, the pink balls will help enlarge the tooth size. And so you can see as we go through this, we will move and adjust and lengthen and shorten until we feel like the teeth are in the correct position. So we'll continue to go through this. There's 2 more teeth to add. You'll see that we continue to do the same thing. Change the size and shape to make sure that we feel like it is waxed up to an ideal size, shape, and form. Rotating it into position, making it look like teeth. It's a really nice feature that Blue Sky Bio has, that you can do this so easily. You can do this many ways. You can wax it up with another software, import it in with the teeth already waxed up. You can print the models, wax it up analog with real wax, rescan it in and merge it in. You can have the lab wax it up, scan it and make it into an STL file and merge it into the software. This just shows you a design feature that Blue Sky Bio already has in place, that you can add teeth. It gives you a really good idea of the position, size, location of those teeth, so when you're planning your implant placement, it'll be in the correct position. There you go. Again, we'll just fine tune it, looking from every angle, to make sure it looks like teeth and we don't have them in some odd position. You can see here the cervical area of the tooth looks a little bit too pronounced, so we're trying to bring that back in so we can plan our implants for the best emergence and position possible. Once we have them to where we feel it's the right position, we'll lock them in place. It's using that tooth tile or panel and just clicking on the lock button for each tooth. Now we'll go ahead and add some implants. So you saw before we aligned the cursors in the right position of where we want the implant, and go to the panel to add an implant, and then we select the implant that we feel is the appropriate size and shape and manufacture for this case. In this case, we selected just a small diameter implant to just see how the bone looks. Using the different fields of view, you can position the implant where you think it should go. In this case, we selected a little bit longer implant. It's a Straumann 3.3, and we are trying to position it within the bone to maximize the amount of bone around the implant. Usually, you'll want to strive for at least 1.5 to 2 millimeters of bone circumferentially around the implant, and then keeping the right distance from the adjacent teeth. We'll also usually provide a custom abutment, placing a long, same diameter custom abutment so that we can identify where the abutment exits from the surface of the teeth. And we are selecting the second implant. Again, we use a Straumann, use a similar size and shape, and put it into position where we want, and modify it and move it around until we feel like it comes out the right location. In this case, in that central position where the graft is, provides the best support for that implant, which we could probably utilize a larger diameter implant. But since we're in the mandibular anterior and there's plenty of bone there, to maximize the thickness all the way around it, we use the 3.3. So now we move the cursors over to where we'd like to put the second implant, select the correct implant size and type and manufacture, and we go through the process again of lining up the implant where we would like it to be. We're striving to keep them parallel and exit out the cingulum of the mandibular anterior teeth so that we can provide a screw retained restoration as our ideal restoration of choice. Once we feel like they're in the appropriate position, we lock them into place, and we can design our guide to be printed in our Formlabs 2 printer. So I turn off the custom abutments and I turn on the guide sleeves. You need to know your guide sleeve dimensions, which in this case they are Straumann. They have a nice guide panel in their PDF manual that'll tell you what to change the sizes to. I'll often turn off the teeth as well because the teeth kind of get in the way in our process. We will also start changing the sizes of the guide sleeve diameters. So you'll see the guide hole diameter. You want to use the outer sleeve diameter, and in our case we always add about 0.02 to allow it to fit more appropriately after printed. The height of the sleeve, you will just use the exact height of the sleeve recommended by the manufacturer, and then your offset is the height that your platform of your guide is from the platform of the implant. And you can determine that based on where the tissue is, the bone is, and the amount of space you have in the patient's mouth. So we go through both implants and change the diameters and settings of the guide sleeves to be the appropriate size and shape. And then, like I said, we'll go and turn off the teeth so they are not in the way of our guide fabrication process. Often I will just eliminate the teeth from the guide planning. So here you go, we just turn the teeth off, and like I said, often we will just completely eliminate them if they don't turn off all the way. But since we clicked on not to being able to view them, now you can see where those sleeves are and if your planning will work with the guide parameters that you set up. At this point on the guide panel, you will click the resolution. We usually use high or very high. I'll click on lock the implants in place and use the anatomic brush. We will then draw the curve. So you can see there we clicked on draw the curve, hit select, and you can draw the shape of that outline of the guide. Then you'll click on edit the curve, and now you'll see these little balls attached to your line. That allows you to reposition the line to exactly where you'd like it more appropriately. We try to keep the guide at least 2 teeth on either side if it is a tooth supported guide. In this case, we're trying to avoid the brackets and arch wire that are on the braces as well. And so we'll just move them around until we feel like we're okay. Ideally, you would likely remove that arch wire when you made your scan so that it wouldn't interfere with your guide during surgery or during the fabrication process. Once you've moved your outline to where you think it should fit or be, you will actually create, you can now right click and create windows if you'd like. That's pretty easy to do. We didn't need them in this case, so we clicked on create surgical guide. Those parameters, if you know them, go ahead and use them. In this case, we aren't using them. Most of the time we don't. Once the guide is created, you now have something to export to be printed for your software. And you can see where we didn't remove the arch wire, it felt like it needed to create a window to allow it to see over that. Now if you would like, you can export this to be printed. So you'll go to File and export the guide. Oh, sorry, we are actually going to export the drill report. So we went down to screenshots and drill report, created a drill report, and we exported that and saved it in the patient's folder. That allows you to see the different sections and views of the implant and the guide parameters. Now we will save or export the guide. So we go to File, Export Data, and this window will pop up, and you'll unclick everything except for the surgical guide. Then you'll click OK, and you will save it into the patient's folder or wherever you would like to save it to print it, and now it is ready to move on and print in your printer.